Today we are going to study a new chapter. The name of the next chapter is rotational motion. Okay. Everyone give the heading. Rotational motion. That is the new chapter. Everyone give the heading. Rotational motion. That is our new chapter. Earlier, previous chapter we studied is a linear motion. Motion is only in one single line. Linear motion. In rotational motion, okay. In rotational motion, most of the question in rotational motion is combination of rotational motion and linear motion. So we need a basic of linear motion also. Means we need a basic of basic theory. Then we need a basic of friction. After that we need a basic of linear motion and some concepts of this chapter also. Okay guys, try to see the scenario. Okay, so everyone give the heading. Next chapter that we are going to study is a rotational motion. Now in that first point we are going to study is what? Comparison between linear motion. Okay, everyone give the heading. Comparison between linear motion and rotational motion. Everyone give the heading. Comparison between linear motion and rotational motion. So we are going to compare here linear motion and rotational motion side by side. Okay. Whatever the concept we studied in linear motion, the same concepts we are going to revise once again, and similar concepts we are going to apply for the rotational motion. Okay, everyone given the heading. Now the next point is here guys. Now so we are going to study comparison between what? Linear motion and rotational motion. So what is the comparison? Okay, so now we are going to form a table. Comparison between our first point is what? Comparison between linear motion and rotational motion. Okay, so try to see the scenario here. So here on one side linear motion and on another side what we have? Rotational motion. Okay, try to see the point. Okay, on one side what we have? Linear motion, another side rotational motion. Now guys, can you tell me which point we studied first in linear motion? Guys, go to the theory of linear motion, everyone. Just go to the theory of linear motion and can you tell me which first point we studied in a linear motion? Can you tell me which first point we studied in a linear motion? Displacement, correct? Okay. So first point we studied in a linear motion is what? Displacement. By which symbol we denoted displacement, guys? By which symbol denoted displacement? Yes, okay. SI unit of displacement is what, guys? Is meter, okay? Okay. So first point we studied in a linear motion is what? Displacement. SI unit is what? Meter. Now, in rotational motion, so in linear motion we have a displacement, but in rotational motion, guys, whenever any object rotate, okay, whenever any object rotate in that scenario, so here first point will be what? Angular displacement. What will be the first point here, guys? Angular displacement, and this angular displacement is denoted by what? Theta. Okay, and SI unit of angular displacement is what? What is meant by basically angular displacement? Means angle cover. Suppose this is what? A disk. Okay, so its position is what? Suppose this is what? One position. Okay, so it coming from this position to this position. So this is what? Angle covered by this disk, theta. Okay, guys, are you getting my point? So SI unit of angular displacement is what? Radian. What is SI unit, guys? Angular displacement. Angular displacement of SI unit is what? Radian. Okay, you got the meaning of means how much angle covered. Okay, so here we will say angular displacement. Okay, everyone please write down first, here first point, here first point. Okay, everyone please write down. Now the second point, what is the second point we studied in a linear motion, guys? What is the second point we studied in a linear motion? What is the second point we studied in linear motion? Velocity. Velocity is denoted by what, guys? Small v. Okay. Now, try to see the scenario. SI unit is what, guys? Velocity. Meter per second. Okay, try to see the scenario here, everyone. Don't write anything. If v is constant, guys, if velocity is constant, if v is constant, then v is equal to what we can write? If velocity is constant, everyone, if velocity is constant, how we defined v? V is equal to what, guys? What we can write? What we can write? V is equal to? No. If v is equal to constant, then v is how it is 0. It can be any value. If velocity is constant, then acceleration is 0. Guys, v is not 0. So, how we define velocity then in that scenario? V is equal to what, guys? Okay, s by t. Okay, everyone getting my point? Try to see the scenario here. Okay, so here, so s by t. Okay, if v is constant, how we define mathematically velocity? S by t. Now, here second point in rotational motion. Here displacement, angular displacement. So, what will be the second point here, guys? What will be the second point here? What we can say? Angular velocity. What is the second point we can say, guys? Angular velocity. And this angular velocity, in one chapter we studied angular velocity, guys. We used, in which chapter we used angular velocity? Balancing. In chapter balancing we used angular velocity. And angular velocity is denoted by what, guys? Omega. Try to see the scenario here. Angular velocity is denoted by omega. So here, meter per second. So can you tell me, guys, SI unit of angular velocity is what? What will be the SI unit angular velocity, guys? Radian per second. SI unit is what, guys? Radian per second. Okay. Here we have written V is equal to constant, then V is equal to S by T. So here what we can say? If omega is equal to constant, guys, try to see the scenario here. If omega is equal to what, everyone? Constant. Then what we can write? Omega is equal to what we can write? Theta by T. Okay, everyone getting my point? Try to see the scenario. Very simple discussion. Guys, if you are good with linear motion chapter, then automatically this chapter rotational motion is very, very easy for you. Please everyone write down second point. Side by side, guys. Properly, everyone. Write down this side by side. Now the next third point what we studied, guys. What is the third point we studied in linear motion? What is the third point we studied in linear motion, guys? Okay, acceleration. Okay, third point we studied in linear motion is what? Acceleration. Okay, good. By which symbol we denoted acceleration? Small a. Okay. What is SI unit of acceleration? Can anyone tell me? Meter per second square. SI unit of acceleration is what, guys? Meter per second square. Okay. Now, if A is equal to constant, what we can write, guys? Acceleration will be equal to what? V minus U by T. This is a relation we have seen. If A is equal to constant, then acceleration is equal to what we can see. Okay, everyone? Acceleration will become V minus U by T. Where what is meant by V? Where what is meant by V? Final velocity in meter per second. Everyone try to say the scenario. U means what, guys? What is the meaning of U? U stand for what? Initial velocity. Very good. Initial velocity in again meter per second. And what is the meaning of T? Time. Okay. This is what we have seen. Then, guys, we have seen if A is equal to constant. Again, if A is equal to constant, then average velocity, V average is equal to what we have seen? U plus V by 2. Okay. If A is equal to constant, U means initial velocity. U plus V by 2 is equal to what, guys? is equal to what? S by T. That is what we have seen here. Guys, are you getting my point? Try to remember the things, whatever the things we studied in linear motion, the same thing we are going to apply for the similar thing, not same thing, similar thing we are going to apply for the rotational motion, everyone. So here in rotational motion, try to see the point here, in rotational motion. Okay, so in this side, what we are written, going to write down the rotational motion. Now, what will be the third point for the rotational motion? Can you guess, guys? Third point. So here, displacement, angular displacement, velocity, angular velocity. So what will be the third point here, guys? Can you guess? What will be the third point here? What will be the third point, guys, here? Can you guess? What will it, which acceleration? Third point. Which acceleration here? Displacement, angular displacement, velocity, angular velocity. So what will be the scenario? Acceleration? What, guys? Angular acceleration. Angular acceleration. Okay. Everyone, are you getting my point? Try to see the scenario. And this angular acceleration is denoted by symbol alpha. Okay. This angular acceleration is denoted by which symbol, guys? It is denoted by symbol alpha. Okay. Try to see the point here. Now, what will be the SI unit here, guys? What will be the SI unit here, everyone? Can you tell me? SI unit will be what for the angular acceleration? What will be the SI unit? Radian per second square. SI unit is what? Radian per second. Very good. If here we have written A is equal to constant. So here what we can say? If alpha is equal to constant, guys, try to see the scenario. Then A alpha is equal to what we can say? Omega 2 minus omega 1 by T. Okay. Omega 2, try to see the scenario here. Omega 2 minus omega 1 by what, guys? T. Okay. This is the one relation. Okay. If alpha is what? Constant. And then next point is what? What is the meaning of omega 2 here? Guys, what is the meaning of omega 2 here? Where? Omega 2 means what? Guys, can you tell me? What is meant by omega 2? Final angular velocity. Very good. And what will be final angular velocity in what? Radian per second. Omega 1 means what? Initial angular velocity in radian per second. Okay, guys, are you getting my point? Try to see the scenario. And what is the meaning of T? T stand for time. Time meaning what, guys? In second. Okay. Now, here we have written if A is equal to constant, V average is equal to U plus V by 2 is equal to S by T. So, here we can say if alpha is equal to constant, if what, guys? If alpha is equal to constant, what we can say? Omega average means average angular velocity will be equal to what, guys? Omega 1, initial angular velocity plus final angular velocity divided by 2. Okay, see the scenario is equal to here S by T. So here what we will have, guys? Theta by T. Okay, everyone getting my point? Anyone have any doubt in these discussions? Okay, so here we have an acceleration. Here we have an angular acceleration. Okay, here unit is what? Meter per second square. Here unit is what? Radian per second square. Okay, guys, so please everyone write down this side by side. Write down systematically, everyone. If you want good marks in mechanics, not only marks, if you want to pass mechanics, your revision must be in proper format. And for revision, your notes must be in good format. Okay, so please everyone write down side by side. Now, guys, what is the next point we studied in the linear motion? What is the next point we studied after the acceleration? What is the next point we studied in a linear motion? Guys, can you tell me? What will be the fourth point? Equation of motion. Very good. What is the fourth point we studied, guys? Equation of motion. Okay, everyone, try to see the scenario. So, equation of motion. Okay, don't write anything, don't do anything. Just observe what is the condition for, guys, valid for when A is equal to what? Constant. When acceleration is constant, then and then we can apply equation of motion. What is the first equation of motion here? What is the first equation of motion, guys? V is equal to U plus AT. Second is equal to what, guys? S is equal to what? UT plus what, guys? Half AT square. Okay, try to see the scenario. And what is third one, guys? V square is equal to what? U square plus 2AS. Okay, everyone try to see the scenario here. Very, very important discussion. So this is what the equation of motion we studied, and this equation of motion is valid for when our acceleration is what, guys? Constant. Okay, try to see the scenario. When acceleration is what? Constant. Okay, now the next point is what? So fifth point will be what? Guys, you have not written anything, na? Before going further, guys, here 1 minute, one important point I want to give you. Okay, in this fourth point, write down one extra point here. Okay, before going further, in this third point, add extra point. So, guys, what we can say here? One important point. So, if V is equal to constant at this point in the third point, if V is equal to constant, what about acceleration? 0. Okay, and if if omega is equal to constant here, then here what we can say? Alpha is equal to 0, guys. At this point here in rotational motion, means here in third point, at these two sentence, this one in acceleration column and this one in here, third point here. And always remember one point, while I am writing, don't write anything, whenever I am dictating anything, whenever I am explaining anything. So that's the rule of the class. Okay, guys. So now, this is what equation of motion in linear. Okay, equation of motion. Okay, or we can say equation of linear motion. What we can say here? Here we will say equation of what, guys? We will say equation of what? Linear motion. That is what we can say. Equation of what, guys? Linear motion. Okay. Now try to see the scenario here. The fourth point will be what, guys? What will be the fourth point? Equation of what, guys? Equation of what we can say here? Equation of rotational motion. So this equation of rotational motion is valid for what, guys? If A is equal to constant. Okay. So equation of rotational motion is valid for what? What we can say? Can you tell me, guys? Valid for what? Valid for what? Here A is equal to constant. So in linear motion we have acceleration. In rotational motion what we have, guys? Angular acceleration. So here valid for alpha is equal to constant. So guys, now tell me here. V means what? Final velocity. U means initial velocity. A stand for acceleration. T stand for time. Okay. Instead of V, what we can write, guys? Instead of V, what we can write? Instead of V, here what we can write? Omega 2. Final velocity, final angular velocity. So omega 2 is equal to omega 1 plus alpha t. Second point, guys, here S ut plus half at square, guys. Just speak, guys. Okay. Instead of S, what we can write here in rotational motion? What we can write, guys? Instead of S, what we can write? We can write S means what? Displacement, angular displacement. Okay. So angular displacement is denoted by which symbol? Theta. So instead of S, guys, what we can write? Theta. Then ut plus half at square. So u means what, guys? Omega 1 t plus half alpha t square. Okay, guys, are you getting my point? Try to see the scenario here. Now can you tell me third expression? Guys, speak up, guys. Here what we can write here? What we can write, guys? Omega 2, okay, very good. Omega 2 square is equal to what, guys? Here, U. Here what we can write? Omega 1 square plus what, guys? 2as. So here what we can write? 2as. 2 alpha, okay, further 2 alpha t. Okay, very good, guys. So this is what a equation of motion in rotation, equation of rotational motion. Okay, guys, are you getting my point? Try to see the scenario here. Okay, please everyone write down the fourth point side by side properly. Now, what is the next point that we are going to study here? Okay, now till now we studied here up till now. Okay, now the fifth point here is, guys, try to see the fifth point here. So here in linear motion, we are dealing with mass. Mass is denoted by small m, and SI unit is what, guys? Kilogram. Okay, but in rotational motion, instead of mass, wherever we are mass in that expression, we are going to use mass moment of inertia. What we are going to use, guys, in rotational motion? Fifth point, mass moment of inertia. This is a new term for you guys. Don't worry about this term. We are not going into that much detail, and we don't need that term in that much detail. Okay, whatever the formula I am going to give you, you have to memorize that formula. Mass moment of, see, there are two types of inertia in mechanics. One is mass moment of inertia, another one is area moment of inertia. Area moment of inertia will come into the strength of material in shear force and bending moment diagram. Here, mass moment of inertia. Mass moment of inertia. Mass moment of inertia. And this mass moment of inertia is denoted by symbol I. Okay. Mass moment of inertia. Area moment of inertia is also denoted by symbol I. But units, the difference is what their units are. Mass moment of inertia and area moment of inertia. Whenever we are going to the strength of material, okay, in that scenario we will see. So mass moment of inertia is denoted by I. Okay. And area moment of inertia is also denoted by I. Now this I will be equal to, you have to memorize this relation. I is equal to what, guys? mk square. What is meant by I relation is what, guys? Don't go into that much detail. Don't try to understand anything about mass moment of inertia. Just memorize the relation. I is equal to what, guys? mk square. That is important. This is much only relation is important to us from exam point of view. And where m stand for what, guys? Mass. In what, guys? Kg. And k, small k, means what? Radius of gyration. Some people may say gyration, some people may say gyration. Whatever the word you want to pronounce, you can use that one. So radius of gyration means some of my teacher during my masters or during my graduation, some teachers use gyration, some use gyration. Okay, so whatever the word you are comfortable or whatever the, so here radius of gyration. Okay, and it is in what? It is in meter. So guys, here m is in kg, k is in what? Meter. So what will be the unit of I, guys? Can you tell me unit of I? What will be the unit of I? No, not only kg meter, mk square, na guys? Not kg meter only. mk square, kg meter square, guys. Okay, so its unit is what? Unit of I is what? Kg meter square. Okay, everyone getting my point? So please everyone write down this one side by side. Here mass moment of inertia. I will explain you its use, how it is useful, means comparison. Please everyone write down this fifth point. Now the sixth point here is what? Sixth point here is what? In linear motion is due to force. Force is denoted by F. SI unit of force is what, guys? SI unit is what? Newton. Okay. Okay. Now here rotational motion is due to what, guys? torque. Rotational motion is due to what? Torque. Torque is denoted by what? Capital T. And SI unit of capital T is what? Is Newton meter. Okay. Sometimes we may say torque, or in some word twisting moment also. Okay. But when we are doing a torsion, in that scenario we will use twisting moment. But for just now in rotational motion we will use only torque. Okay. So please everyone write down 6 point. Force here, here torque. Now guys, the 7th point will be what guys? What will be the 7th point? So here, Newton's second law of, guys, everyone try to see the scenario. Newton's second law of linear motion. What is the Newton's second law of linear motion, guys? Can you tell me Newton's second law of, what is the expression we studied for Newton's second law of motion? Summation of forces will be equal to what, guys? Summation of forces will be equal to what? Ma? Okay. So summation of forces will be equal to what, guys? Mass into acceleration. So that is what our Newton's second law of motion. We will say Newton's second law of linear motion. Everyone getting my point? Try to see the scenario. Now similarly, here we have seen Newton's second law of linear motion. So here 7th point will be what, guys? What will be 7th point here? Newton's second law of what? Newton's second law of what, guys? Newton's second law of what? Newton's second law of rotational motion. Very good. Newton's second law of rotational motion. So Newton's second law of rotational motion will be what, everyone? Can you tell me expression for Newton's second law of expression, guys? See, here F, instead of F, what we can use here, guys, in the rotational motion? Torque. Yes, torque. Yes, correct. Instead of mass, what we can use here? In linear motion, we have a mass. In rotational motion, what we have, guys? I stand for mass moment of inertia. Here we can use acceleration. Here we can use what? What we can use here, guys? Instead of A means what, guys? Angular acceleration. And what is the symbol for angular acceleration, guys? Speak up, speak up. What is that? Alpha. Very good. Speak up, guys. See, if you speak during the class, the important benefit is what? If you speaking with me during the class, important benefit what? You will not feel sleepy. That's the first important benefit. And second benefit is that, guys, I feel that whatever the thing I am telling you, I feel that you are getting my point. So I feel more interest in the class. Okay. So please be speak with me. Now, so here, summation of what, guys? What we can say? Summation of what? Torque is equal to what? I into alpha. Okay. So this is what? Newton's second law of what, guys? Rotational motion. So in this chapter, we are going to use both the scenario side by side. In some questions, means a few question is there. It is a combination of linear motion and rotational motion. Okay. So whenever linear motion, we will use this one. Whenever there is a rotational motion, we will use this one. Okay. Please everyone write down 7th point. Now guys, what will be the 8th point? Okay, try to see the 8th point here. 8th point will be what? Momentum. Momentum means what, guys? Mass into velocity. What is momentum, guys? Mass into velocity. So that is a momentum. Now here what we can say? Here 8th point will be what, guys? In rotational motion, angular momentum. So guys, can you tell me expression for angular momentum, guys? Can you tell me expression for angular momentum? Anyone? So here mass. Instead of mass, what we can write, guys, here? Instead of mass, I. Okay, very good. Here V. Instead of V, what we can write, guys? Omega. Okay, everyone getting my point? Try to see the scenario here. So angular momentum, please everyone write down 8th point side by side. Momentum means linear momentum. Angular momentum. It has a symbol, but we are not introduced that symbol. We don't need it. It has a symbol, means sometimes we denote momentum by P and angular momentum by L. Okay. It has a symbol. It has a symbol. Momentum has a symbol, but we are not using it. We don't want that much confusion, because only in few exams, in few questions we need a momentum. So we keep it as only momentum only. It has a symbol. A linear momentum in few books used P and rotation angular momentum used by L. Okay. But we will not introduce that one. Okay guys, now the next point is what? Ninth one. That is a very, very important point guys, ninth point. Okay. In this chapter, we are going to use this concept lot of times. Conservation of momentum. See the word, everyone. Conservation of what? Conservation of momentum. Now what is meant by conservation of momentum? What is the meaning of word conservation of momentum? Okay. See, whenever there is a linear motion, there will be a collision, strike. Okay. Or two objects will be collision, strike. Okay. So total, what is meant by conservation of momentum? Okay. We studied this concept in our linear motion, but we have not used there in linear motion. Okay. So conservation of momentum, total momentum guys. Total momentum. Everyone try to see this concept. Total momentum. Total momentum before collision. Sometimes may use word collision, strike, impact. Both are the same meaning. Okay. Total momentum before collision will be equal to what guys? Total momentum. Total momentum. What we can say? Total momentum just before collision. This word is very important. Just before. Total momentum just before collision is equal to what guys? Total momentum. What we can say? Total momentum just after collision. Okay. Everyone try to see the point here. So this is mean by what guys? Our conservation of momentum. Okay. Very, very important point. Conservation of momentum. Okay. 9th point here. Instead of momentum, what we can say? Conservation of what guys? Conservation of what? Conservation of what? Angular momentum. Conservation of what guys? Conservation of what? Angular momentum. Try to see the scenario. Now in linear motion, we have a collision, strike or impact. Okay. All the meaning means instead of collision, what the word can have? Instead of collision, what the word can have? Strike or impact. Means all the words has the same meaning. Collision, strike, impact. Okay. Now here conservation of angular momentum. Guys, in rotational motion, when we will have an impact, when two bodies collides each other in rotational motion, what will be that scenario? In linear motion, a simple scenario. There is one car, another car, there is their collision. Okay. Or two persons come together and they have collide. Okay. Collision. Okay. That is a simple scenario. But in linear motion, in angular motion, what we will have guys? In angular motion, what we will have? When we have a similar scenario of this one guys, what we will have guys? In angle, yes, in clutch or two gears. Okay guys, clutch scenario. A clutch means in clutching what is happening? Means see, one shaft is there. In case of clutch, what is happening guys? One shaft is there. Input to output. Okay guys, what is the scenario? Clutch, one gear to another gear. Okay, gearing. Guys, are you getting my point? Means whenever we are using, see, in rotational motion, suppose this is what one shaft, one input shaft, and we want to transfer its power to the another shaft. Okay. So what we have to do for that purpose? For transferring this shaft power to this shaft power, what we are going to do? Suppose initially this shaft is stationary and initially this shaft is moving. Okay. This shaft is what guys? Moving. Okay. But if you want to power up this to If you want to transfer power of this shaft to this shaft, what is happen? What we will use clutch, okay? Because initially it is stationary. So we want a proper smooth power transmission, and if we want smooth power transmission, what we will use, guys? Means we want to transmit this shaft power to this stationary shaft. This shaft is moving, guys. This shaft is what moving. So what we will use? We will use clutch. So in case of clutching, what is there? Guys, conservation of angular momentum. Okay. So try to see the scenario. So in case of clutch, what we will have? A conservation of what, guys? Angular momentum. Means, so what is the word here? We can use total angular momentum. Guys, see the wording here. What is the conservation of angular momentum? Total angular momentum. See the wording here. Total angular momentum just before clutching or just before engagement. Okay. Just before clutching or just before what, guys? Engagement. Means clutching, engagement, gearing. Okay. All these are the similar word. Okay. So total angular momentum just before clutching or just before engagement will be equal to what, guys? What we can say? Total. Say it, guys. Total angular momentum. Say it with me. Total angular momentum just, what we can say, guys? Total angular momentum just after engagement. Very good. Okay. And what is the another word for engagement? We can use clutching. Okay, guys. What is the another word for engagement? We can use, guys. Another word for engagement means what? We can use what, guys? See, collision, strike, impact. Here, clutching. Okay, everyone getting my point? Try to see the scenario here. Okay, everyone got the, so conservation of momentum, conservation of angular momentum. Conservation of momentum is what? Total momentum just before collision will be equal to what? Total momentum just after collision. And conservation of angular momentum is what, guys? Total angular momentum just before engagement or clutching is equal to what, guys? Total angular momentum just after engagement. Okay. During numerical, we will clear this concept. So don't worry, guys. We are going to do a lot of numericals on this one. So don't worry about. We will clear all concepts on this chapter, on this one also, on this linear momentum, and on this one also. Okay. So please, everyone, write down this 9 point. Very, very important point, guys. Make this point as a star point. Because most of the students get confused with these points, So don't forget this one, everyone. Now, 10th point is here, guys, what? Impulse of a force. Impulse of a force. Impulse of a force is equal to what, guys? F into T. Okay. Impulse of a force is equal to what, guys? F into T. Or impulse of a force is equal to what? Force into time. Or M into V minus U. Okay. Impulse of a force is equal to what? Force into time. Or M into V minus U. That is what the impulse of a force. And impulse of a force unit is what? In force unit is what? Newton. Time unit is what? Second. So, in Newton second. Try to see the scenario here. Now, so here what we will have? So here impulse of a force. Okay. Now what is meaning of impulse of a force? Means how much duration that force applied on that object. Okay. Impulse of a force meaning of what is what? In how much is the effect of force for that particular duration. That is the meaning of impulse of a force. Now then, impulse of a torque. See the scenario, impulse of a torque or angular impulse, guys? Impulse of a torque or what? Angular impulse, okay? Impulse of a torque or angular impulse will be equal to here F into T. So here what we can say? F into T. Here what we can say, guys? Torque into time, or what we can say? I into omega 2 minus omega 1, and its unit is what? In Newton meter second. Okay guys, are you getting my point? Try to see the scenario here. So this is what the impulse of a torque or angular impulse. This angular impulse word will ask in one question, guys, in future when we are doing clutch, guys, when we are doing clutch, especially conical clutch, in that scenario there is a one word will come. Okay, see, whatever this rotational motion means, whatever the concepts we are studying now will be useful in rotational motion. Further, clutch means this concept is useful in lot of chapters, guys. In torsion also these concepts are useful, means flywheel, clutch, okay, gear, all these chapters, the concepts that we are studying in this rotational motion is useful there. Okay, so in every chapter is linking. If you miss any chapter, then there will be problem for you guys, so please do every, means first of all basic theory, after that we studied balancing, after that we studied friction, after that we studied linear motion. Now we are studying rotational motion. After rotational motion we are going to study gear, after gear we are going to study flywheel. Okay, so every chapter is linked with other chapter, so please don't miss any chapter, so please everyone. Now try to see the next point here. What is the next point that we are going to study? What is, guys, can you tell me what is the more point, which are the more point we studied in linear motion? Any more point we studied in linear motion that we have not covered till now? Can you tell me any point? Guys, go to the linear motion theory. Just go through the linear motion theory, everyone. Okay, any more point, guys? Equation of motion in gravitational field. Okay, other than that, guys, we have not covered here. Other than that, guys, other than that equation, guys, kinetic energy. Okay, good point, guys. Kinetic energy. Okay, so 11th point is what? Kinetic energy. So we will say linear kinetic energy. Linear kinetic energy. So what is the expression we have studied there, guys? Linear kinetic energy will be equal to what, guys? Kinetic energy will be equal to what is the expression we studied? Kinetic energy is equal to what? Half mv square. Okay, that is the expression, guys. This expression is very important. Means it is useful in heat also. Means this expression can be useful anywhere. Okay, so half mv square, this is very basic expression. And what is its unit, guys? Energy unit is what? In joule. Okay, not joules, only joule. Okay, so linear kinetic energy, 11th point here. So what we can say? Rotational, what, guys? Rotational kinetic energy. So what is the rotational kinetic energy? What is the expression we can write, guys? Can you tell me what is the expression for rotational kinetic energy? Observe this one. Half, I will keep it like that. After half, here we have a mass. In rotational motion, is instead of mass, what we can use, guys? I. Okay, see the scenario here. I stand for what? Mass moment of inertia, mk square. Mass, mk square, that is the relation for I. Instead of V, what we can use here, guys? Instead of V, what we can use here? Omega, guys. What we will see? Omega, okay. Half I omega square, okay. Omega means angular velocity. So that is what our kinetic energy, linear kinetic energy, and this is what? This is what our linear kinetic energy, everyone. This is what our rotational kinetic energy. Here unit is what, guys? Say energy. Whether it is a linear or rotational, unit is what, guys? In joule, okay, capital J. And if you want full name, you will use, in that scenario, this J must be small, guys. Remember, see, if you are using abbreviation for Newton as a unit, then capital N. But if you are using full name, means 1 Newton or 1 Newton, in that scenario this N must not be capital, guys. Here this Newton is not a person name in this scenario. For us Newton is what? Unit. And if you are full name, then this N must be in small. These are the very small thing. If we are using abbreviation, same with joule, 1J. If you are using, guys, are you getting my point? If you are using full name, then this joule, J must be in small. Same with what? Same with what, guys? What? If you are using abbreviation, capital W. But if you are using full name, then W must be what? Small. Okay, guys, try to see the point here, everyone. Same with the joule also. Because here joule is not a person's name. Okay, here joule is, what is joule here? Unit. Okay, and if you are using full form of the joule, then this J must be small. If you are using abbreviation, then capital J, guys. Try to see the point here, everyone. These points are very important. So you should be good with these small things. Please everyone, write down 11th point. Okay, what is the next point we studied in linear motion, guys? Is there any other point we have not covered here? What are the other points here? Okay, so after potential energy, guys, work. Okay, correct, good. So here 12th, guys. Okay, so linear work, 12th point, linear work. So work will be equal to what, guys? W is equal to what? Force into what? Displacement. F into S. That is what relation we have seen. And again, what is the unit of work, guys? What is the unit of work? Can you tell me? In joule. Okay, work is also joule. Now here, 12th point here, in rotational motion, what will be the 12th point? Rotational work. Okay. So here, linear work is created due to what? Force. Okay, linear work is created due to what? Force. So rotational work, W will be equal to what, guys? Instead of force, here what we can say? Here linear motion is due to force. Rotational motion is due to what, guys? Instead of force, here what will be the scenario? Torque. Okay, good. And instead of yes, here yes, what we will have here, guys? What we will have? Displacement. Okay, angular displacement. Okay, what we will say? Angular displacement. Okay, so T into theta. Again, work. Okay, so here again unit is what? Unit of work will be what, guys? In joule. Okay, everyone try to see the scenario. What is the next point in linear motion we studied, guys, after work? What is the next point we studied? Power. Okay, so 13th point, linear power. So what is the relation for power we have seen there? So basic relation for power is equal to what, guys? Work by time. See, how to define power? Power means what? Work done per unit time. See, a bulb, okay, a bulb, a tube light, okay, a bulb. Suppose one bulb is of what? 20 watt bulb. So power of the bulb is what? 20 watt. Okay, suppose one bulb has a power of how much? 20 watt. What is the meaning of 20 watt, guys? This bulb in every second, what is the, in another form we can write it as like a 20 joule per second. What we can write, guys? In every second, if bulb has a, means we say give the bulb of 20 watt. Now what is the meaning of 20 watt, guys? In every second that bulb consumes 20 joule of electricity or 20 joule of electrical work. Electricity means what? One type of work, means electrons are moving there. So meaning of 20 watt means what? 20 watt bulb means what? In every second, suppose, no, another example, a power plant. Okay, so 500 megawatt power plant. Okay, suppose a bulb, power plant of what, guys? 500 megawatt power plant. Now what is a power plant has a capacity? Okay, suppose one power plant. Okay, one power plant. Okay, electricity production plant. Okay, power plant has a capacity of 500 megawatt. Now what is the meaning of 500 megawatt? In every second, In every second, 500 megawatt means what? In every second, it is producing 500 megajoule of energy in every second. Okay guys, are you getting my point? So what is meant by work? Sorry, what is meant by power? Power means what? Work done per unit time. What is the meaning of power, guys? How you define power? This is very important, because in heat, those who want to give the heat, so there is few times we use work, few times we use power. Okay, so you have to understand this meaning of word power. So what is meant by word power? Power means what? Work done per unit time. Means the bulb has a what? 20 watt, means in every second that bulb is consuming 20 joule of electrical work. If power plant is of 500 megawatt, it means in every second that power plant produces 500 megajoule of work. Okay, guys, are you getting my point? Everyone getting my point? Try to see the scenario here. So you got it. What is meant by power? Power means what? Work done per unit time. So work done per unit means time means what? Work by time. So here what we can say? Work means what? Force into displacement. So by time. So what is meant by S by T here, guys? What is the meaning of S by T? S by T means velocity. So what we can write? Power is equal to what we can cite? Linear power is equal to what we can say? Force into velocity, and unit is what, guys? Watt. Everyone getting my point? Okay, power. Linear power means what? Force into velocity. Now we will come to the rotational power. Same scenario will be same. 13 point. Rotational power. Everyone try to see the scenario here. Huh? So rotational power. Everyone observe the things. So here we have work upon time. Power means basic definition. Basic definition means what? What is the basic definition of power? Work done per unit time. What is the basic definition of power? Work done per unit time. So here F into S by T. So here rotational work is what, guys? Torque into theta by T. Torque into what, guys? Torque into theta by T. And then, so what we can say, guys? So power will be equal to what? T. Theta by T means what, guys? Theta by T. What is that theta by T? Angular velocity. So here what we can say? T into omega, and that is what? Our rotational power. So whenever linear motion, guys, if you remember linear motion, there is one question. In linear motion, whenever linear motion, power is force into velocity. In linear motion question. Whenever there is a rotational motion, power will be equal to what, guys? Torque into omega, or omega means what, guys? Or few times. Okay, so this is what the power means, what? T into omega. 1 minute, I want to tell you one important point. Now see the point here, everyone. Okay, next point is here. I want to explain you one important point. I have a little space here. I will use here. See, so what we can write? Power is equal to what we can write, guys? T into omega. Okay, anyone have any doubt in this? What is the unit of power? Power, any type of power, guys, whether a linear power or rotational power, means power in linear motion or power in rotational motion. So unit is what by default? Watt, capital W. If you want to write down small, means complete name, then small w, A-double-A-T, watt. Okay, so see the point here. Few times you may use, so omega means what, guys? 2 pi n by 60. Omega means what? 2 pi n by 60. Okay, omega means what? 2 pi n by 60. Okay, we have used this relation in our balancing. So in earlier standard you have used power is equal to what, sir? So here if you arrange this relation, we can write it like 2 pi nt by what, guys? 2 pi nt by what? 60. Okay, so this is another relation of power, rotational power. So whenever there is a rotational motion, we can use this relation T into omega, or we can use relation 2 pi nt by 60. Again, power means what? In what? Watt. Guys, units are very important. Please observe the units. If I have done any mistake, please let me know. So linear power, rotational power. Okay, so please everyone write down this one. Whenever there is a linear motion, power will be equal to force into velocity. Whenever there is a rotational motion, power is equal to T into omega, or 2 pi nt by 60, because omega means what? 2 pi n by 60. We studied this in balancing, guys. Please everyone. So this is all about comparison between linear motion and rotational motion. Okay. Now try to see the next point here. Now we are going to see a relation between V and omega. V means linear velocity. Omega means angular velocity. Okay. Now try to see the point here. Very, very important discussion. Okay. So now give the heading. Relation between linear velocity. By which symbol we denoted linear velocity? V. Okay, means our velocity. And what guys? Angular velocity. And which symbol we denoted angular velocity, everyone? Angular velocity is denoted by symbol omega. Okay, angular velocity is denoted by symbol omega. Everyone try to see the scenario here. Now, so there are questions in which linear motion and rotational motion together. Okay, see, there is one disc or pulley. Here pulley is not a smooth pulley. Try to see the scenario. In this chapter, pulley is not a smooth pulley. Whenever the pulley is smooth, in that scenario, there is not a rotational motion of the pulley. So this is what a pulley, not a smooth pulley. Remember my point. Okay. So this is what a one mass is here. Okay. So mass m is here. Now this pulley will have what guys? The pulley has a what? Rotational motion. This pulley has what guys? Rotational motion. And this mass m has what guys? What this mass m has? Means if this pulley rotate like this, what will happen? Mass m will go what? Mass m will go upward. Okay, so it has a linear motion. Okay, so here we have a what guys? In case of rotational motion, what we have? We have omega and alpha. In case of linear motion, what we have? V and A. Okay, guys, are you getting my point? Okay, so try to see the scenario here. So relation between linear motion and angular velocity. So this disc, okay, in case of linear motion, what we have? In case of linear motion, what we have guys? Omega and alpha. Suppose this disc has a radius what guys? This disc has a radius R. Okay, this disc or pulley, it has a radius what? R. Okay, everyone getting my point? So here V is equal to what guys? Linear velocity is equal to omega into radius. Everyone getting my point? So here V is equal to what? Omega into radius. Okay, so this is what a relation between angular acceleration, linear velocity and angular velocity V and omega. Now the next point, 1 minute guys, don't write anything. So in linear motion we have a V and A. In angular motion in rotational motion or angular motion, we have what? Omega into alpha. So we have seen relation between V and omega. V is equal to omega into R. Okay, you got comparison guys? V is equal to omega into R. Now try to see the next point. Relation between what guys? Linear acceleration and angular acceleration. Okay, what will be the next point? Relation between what guys? Relation between what? Linear acceleration. Which symbol we have used for linear acceleration, everyone? Which symbol we have used for linear acceleration? Which symbol we have used? We have used symbol A. And what guys? Linear acceleration and what? Linear acceleration and what? Angular acceleration. And for angular acceleration, which symbol we have used guys? Alpha. Okay. So alpha. So V is equal to omega into R. So similarly, A is equal to what guys? Alpha into R. Okay. Everyone getting my point? So here this disc has a angular velocity. This disc has a angular acceleration. This mass m. Mass m has what guys? Velocity and acceleration. Okay. Everyone getting my point? Try to see the scenario here. Okay. So first of all guys, give this heading. Draw this drawing. Okay, write down V is equal to omega into R. Below that, after this one, give this heading and write down this one. Okay, everyone, please write down. Next point that we are going to study is what? Torque due to, guys, give the next heading. Torque due to tangential force. Torque due to what? Tangential force. Okay. Everyone give the heading. Torque due to tangential force. Okay. Suppose this is what a disc here. This is what a disc, everyone. This is what a disc. Okay. On that disc, okay, there is one rope is there or wire is there, okay, or cable, okay, and this cable is apply one tangential force, okay. So here there is a tangential force is acting. So on this disc, what is happening? Okay, a tension is here. So there is will be what? A tangential force. So this is what a F tangential. Okay, you got the meaning of tangential force. Okay, F tangential, and the disc has a radius of what? Disc or pulley. Okay, it has a radius what? R. Okay, so torque due to this tangential force is due to what, guys? Torque will be due to tangential force is equal to what? F tangential into radius. Okay, everyone getting my point? Try to see the scenario here. Okay, and what are the scenario where it will be the scenario, guys? Few minutes before we have seen. Okay, disc, we have a mass M like that. Okay, so here there will be a tangential force. Okay, F. Okay, that tangential force. Okay, try to rotate this disc. Okay, everyone getting my point? So this tangential force will create a torque, and that torque will be equal to F tangential into radius. Okay, everyone please write down this point. Yes, you can draw this drawing also. This drawing will give you one idea. Okay, draw this one also. Yes, you can draw this one also. Tangential. Here both the F is what? Yes, both the F, sir. Means here tension. Tension in the cord is act like a tangential force here. Okay, guys. Everyone completed? Okay, good. Very simple discussion, guys. Today is our theory day. Now the next point is here, guys. Write down one note here. Okay, in note first point. In note first point. Mass, moment of inertia. Mass, moment of inertia, guys. Note. Mass, moment of inertia of solid disc. Mass, moment of inertia of solid disc. So, I solid will be equal to what? For solid disc, mr square by 2, where r stand for what? Radius of the disc. Okay, m means what, guys? Mass, radius of the disc, and it is in meter. Okay, so this is what, and what is the unit of I, guys? In kg meter square. Everyone see the unit. Okay, so this is what? Mass, moment of inertia of solid disc, guys. Okay, everyone. Second note. So we have seen solid disc. Then we should see hollow disc also. So second point. Mass, moment of inertia. Mass, moment of inertia. Everyone. Mass, moment of inertia of what? Hollow disc. Everyone try to see the point here. mass moment of inertia, hollow disk or hollow shaft, solid disk or solid shaft. Okay, so I hollow will be equal to, try to see the scenario, I hollow will be equal to what, guys? Small m means mass, capital R square minus small r square by 2. Unit will be in what, guys? Kg meter square. Okay, try to see the scenario here. Now what is the meaning of capital R here? Capital R stand for what, guys? Here plus, not a minus. What is the meaning of capital R? Where capital R stand for what, guys? Outer radius of the disc. Okay, what is meant by capital R? Outer radius of what, guys? Outer radius of the disc. And this outer radius in will be in what? Meter. And small r will be equal to what, guys? Inner radius of the disc. And this inner radius is also in what? Meter. Okay, everyone, are you getting my point? Try to see the scenario here, everyone. So please write down note 1 and 2. Mr square by 2, mr, not k here. This is r. This is r, capital R. Mr square by 2. Okay, here plus, here plus. That's what I told you now. Small r square, plus is here. Guys, there are a derivation of this one, but we will not go into that much detail. Okay, we don't need that points. We need only these two formulas. Okay, everyone. So next point is here what, guys? Energy loss due to friction force or resistance force. Okay, energy loss due to friction force or energy loss due to what, guys? Energy loss due to resistance force. Okay, resistance force. Okay, so this energy loss will be equal to what, guys? Energy loss will be equal to what? F into R into distance. Okay, everyone getting my point? So energy loss will be, whatever the energy loss will be equal to what, guys? Force, resistance force or friction force into distance. Okay, so where Fr stand for what? Fr means what? Resistance force or friction force in Newton. Okay, see, whatever the work we are going to do against a resistance force or friction force, that work is not recoverable to us. Okay, so that will be our energy loss. Okay, so force into distance means what? Work. Okay, and this work means what? Work done against resistance force. So whatever the work we are going to do against resistance force means this resistance force, whatever the work we are going to do, that work is what? Our loss of energy. That energy will be equal to, energy loss will be equal to Fr into distance. Okay, in which we have to do the work. Okay, everyone, please write down this one. Now try to see the next point. We know this one term, guys, conservation of energy. Okay, see, conservation of energy means what? Energy neither created nor destroyed, it transferred from one form to another form. Okay, that is the meaning of conservation of energy. But in according to means equation, exam point of view or numerical point of view, question point of view, we are going to write down one simple term: total energy at initial point. Total energy at initial point. Total energy at initial point is equal to total energy at final point if there is no loss. Okay, but always see the scenario. total energy at initial point will be equal to total energy at final point. But whenever one object going from one state to another state, there will be always some energy loss. So, okay, so is equal to what, guys? So whatever the total initial energy will be equal to what? Total energy at final point, okay, plus energy loss. Okay, you got this relation, guys? Means total energy at initial point, okay, initial total energy at initial point is equal to total energy at final point. Means when we are going from 1 to 2, what will happen, guys? Whatever the energy, the same energy should be there at final point if there is no energy loss. Okay, so whatever the energy at point 1 means initial point will go to where it will go? It will go to the final point. And during motion, what will happen? There may be some friction or resistance, and in that there will be some energy loss. Okay, if they have given resistance or friction, then there will be energy loss. If they have not given any friction, then there will be not energy loss. Okay, so whatever the total energy at initial point will be equal to total energy at final point. And during that motion, what will happen? Then there will be energy loss. If they have given resistance force, then we have to consider energy loss also. If they have not given any resistance force, then we will assume that resistance force is 0, and then there will be no energy loss. In that scenario, this term and this term will equal, then energy loss will be 0. Okay, if they have mentioned there will be resistance force, then whatever the total energy, it will go where it will go, guys? Some will go into the energy loss, and we will get some energy at the final point. Okay, everyone getting my point? Try to write down this relation, everyone.